Okay, well, hello everyone, and thanks for joining the fourth session of the LoongArch Biweekly, and happy to see so many familiar faces back on the meeting. And again, before we start, this meeting is organized by the Loongson Hobbyist Community, a third-party organization unaffiliated with Loongson Technology or any of the companies, entities, and institutions mentioned in this document. Please limit discussion to open information only. We will not answer questions for products and designs currently under development or testing. Please refrain from making political statements or commentary for the duration of the meeting. Opinions expressed in these meetings are strictly of the individual speakers. And I'll quickly skim over how this meeting works. And as usual, if you need to add anything, just get in touch with us, either to me individually or in our group chat. And this meeting is working live streaming on YouTube, and hopefully it'll work this time for the duration of the whole meeting. And now let's move on to upstream development, and we'll start with Cyril Yao again for GCC and bin utils.
For GCC, this is basically something we've already talked about during the last meeting. We have some updates about those. The first is regarding the stack protector fix. The fix has been backported to GCC 13.5. So now it has been backported to all GCC release branches still active. When working on GCC 13, we also found and fixed a build warning introduced by a prior backport for PR 1130 to 33 fix. During the backport, undefined preprocessor directive was unintentionally omitted. So the preprocessor would complain for defining a macro twice. So we found that, and we also fixed that as a easy hack. In the last meeting, we also reported the stack protector fix has introduced a regression causing 64-bit memory operations mistakenly generated for 32-bit LoongArch. The patch to fix the regression has been revisioned to improve readability. The IOD pointer and the ST pointer instructions are now explicitly disabled via the enable attribute of define instruction, instead of subtly relying on the instruction alternative priority rule. The new revision is still awaiting review. The patch for optimizing dot product operations with sign and zero extended operands is also updated. Per Xu Chenghua's suggestion, the test case was rewritten in C and moved to the GCC point target /loonarch/vector/lsx directory. So we can reuse the logic checking if the Sirit CPU supports LSX in the vector point exp test support file, instead of replicating the logic in the test case again. We also suspect the performance issue found in SPEC CPU2026. ASTCENC test is target independent, as the issue is also observed on AH64, and the analysis also points to jump threading, like we've talked during the last meeting. So next page. In the COBOL front end, it was added in GCC 15. And since it was added, we got about 100 test failures on LoongArch. Now Xu Jiahao, James Lawden, and Robert Dubner has concluded that the root problem is target independent. There is a bug in the handling of the section token, and the bug itself causes about 100 of test failures. And there is another invalid test case. The test case uses DL open, but it's statically linked. It's not allowed by glibc. So the test case is invalid, and the invalid test case alone causes a few test failures. In total, there was about 100. Now, both issues are already fixed, so you shouldn't see any COBOL failure on LoongArch if you are testing GCC trunk. But who will run COBOL program on LoongArch? Next page. Now we've got to bin utils. Mengqing has updated the patch fixing the linker bug in the BFD linker involving input objects with and without linker relaxation data and LD-R. LD-R means the linker output will also be a relocatable object file instead of a shared object or executable. The bug breaks the alignment of the segments in the object without relaxation data. So the revision 1 has some issue that the upstream developers have pointed out. It basically inserted some LoongArch specific logic into a function that is supposed to be target independent. So the upstream mandated a change. And in revision 2, I found some stale comment, which is in C++ style, and that's not allowed in binutils code base as the code base is still C89. So the C99 or C++ comments are not allowed. So the stale comments was removed in revision 3. There is also a new binutils patch. It fixes another alignment issue with linker relaxation. This time it's not related to the relocatable linkage. The bug causes the input sections from the input files except the first one to be misaligned. I performed a test on my development system. It has shown the issue has at least caused libffi to fall back to a slower code path. The libffi contains a page which contains thousands of trampolines, and the intentional use of the page is simply map it into a memory page, and then it can be used directly. But as it's misaligned, the direct map will not work. It will simply return error code because mmap mandates the offset in the file must be a multiple of page size. So if those trampolines are misaligned, you are no longer able to unmap them directly. So libffi will write them into a temporary file and unmap that file. So the fallback will be slower. So we recommend distribution maintainers to consider backporting the fix and rebuilding affected packages once the fix lands. Or maybe if you have enough computing power, maybe you should simply rebuild everything, because it's very difficult to tell if a package will be affected by the issue. In libffi, there is a fallback path, so it's only slower. But how about the other packages? Maybe they just expect an alignment and there is no fallback. Then they may mysteriously crash if the alignment is not correct. So maybe a massive rebuild will fix some so-called mysterious problems on LoongArch.
Okay, thank you, Xiro Yao, and we'll move on to Wang Xurui for LLVM, Rust, and Linux kernel.
Okay, so let's begin. For the LLVM part, we have our usual two contributors, Lin Runze and Wang Rui. So, Lin Runze, in the past 2 weeks, he first added support, code gen support for the partial reduce MLA operation and cost helper, get partial reduction cost for the LoongArch port using LSX or LASX. This one is a horizontal reduction involving biased multiply addition. So this is prompted by the SPEC CPU 2026 Stockfish R. So this one's a nice performance boost on that particular test case. 57% performance increase. This one's great. He also optimized the single assigned integer to FP and the unsigned integer to FP, which avoids unnecessary scalarization by utilizing vector extending operations for the floating point conversion. Previously, I think the Scala extension operators were used. Then those properly extended Scala results are shoved into vector register for conversion. So this one's obviously not very efficient. It's also a nice improvement. And finally, he added patterns handling 2056-bit truncate operations using XPIC EV instructions to the table gen description file. And this one's actually, I think, let me check the 2024-85. 2084-5. Yeah, so there's actually a simplification, of the code gen backend code, making it functionally equivalent but simpler to maintain. And in the past 2 weeks, Wang Rui did two also performance improvements. He first added two DAG combination logic handling widening. Let me edit a little bit. Okay, so it's actually a widening vector shift left. I've already fixed the slideshow, but it seems
Yeah, I think it
you have to
refresh. Yes. Good.
So this one's
Yes, it's good now.
widening vector shift left operations. This one's a wild performance increase because previously this one cannot be vectorized at all. Basically, it's like shifting left the original element. So some of the upper bits will get shifted out of existence, will not be shifted to nowhere. So this one's a dramatic, should be a dramatic performance increase. But I don't know whether any algorithm or large scale program makes use of it. Let's see. Finally, he has reduced the redundant masking operations by propagating target data width through the helper, simplify demanded bits for a target node. And of course, all of these are submitted with test cases. So next page, let's move on to Linux kernel. So for the new patch sets in these 2 weeks. We have mobile supporting the ACPI IOVT table. So what's this? This one's for the LoongArch IOMMU driver to be submitted in the future. This is what Mobiboy has said in the cover letter. So it's just simply in the future. I think driver is already in the works in downstream kernels, but I haven't followed closely recently. So let's see. Also, Wang Hongliang has added clocks and clock frequency properties for I2C device nodes for the 2K series device trees. The rest of the patch sets on this page are new revisions of previously covered changes. So move on to the next page. For KVM subsystem, we have a new patch set the past 2 weeks. Mobiboy has done a performance optimization by delivering kernel mode interrupts with the internal KVM API. So what's this for? Okay, I've lost the link. Let's see. Okay, so this one is for delivering interrupt from within kernel land instead of user land. So it's an internal API for currently. So this is just making use of the established API. And he also removed unnecessary print K statement for okay. And George Guo has submitted 2 BPF subsystem changes. One is supporting per CPU move and helper BPF the may go to support. He also made the BPF core reject program unimplemented arena instructions per program private stack and exception handling. So this one's making the BPF core, I think, more sound. I don't know, maybe. Okay, move on to the last page. So as for functional fix, we have Bastien Blanc adding unique build salt metadata to the VDSO object. Let's see. It's simply because the VDSO needs to have a unique build ID in a similar manner to the kernel and the individual modules. It's a simple two-liners. Zhang Sanghong has fixed an issue where Arc Reserve VM core ignores the return value from memblock reserve and leading to a successful message being printed even when it's actually an error. Xie Zhibang has moved the declaration of struct K image to before the first usage. This one's trivial, maybe, but good to code quality nevertheless. Finally, Zhou Binbin has fixed the handling of I/O memory pointer in the video mode parsing code of the 2K 500 BMC frame buffer driver. Okay, that's all for Linux kernel.
Okay, thank you, Wang Xuerui. And for EDK2 or the UEFI firmware, Qian Dongyan or Mars Doge has done a couple things upstream. First of all, he fixed the memory EFI memory RP read-only protection attribute and implemented no pointer detection for LoongArch. He also added preliminary LoongArch support for dynamic tables package. It's basically a framework in which ACPI tables could be generated from uh, um, basically static specifications rather than having to maintain the whole table manually. And third, he fixed the relocation handling of the gen firmware utility, where the section address wasn't updated when translating the addresses for LLVM 64 relocation entries during the conversion. But in, I guess, more visible or interesting situations, he has also, with the help of Claude Code, implemented modern setup package for LoongArch, basically a quote-unquote modern GUI-based setup UI created based on the LVGL embedded framework. This UI framework also comes with custom widgets and mouse support, so we may be getting closer to having a more fancy BIOS setup interface down the line. Also related to UEFI firmware, I think it will be exciting news for some of us. This is what we call a first community release candidate release with many new features. So when it comes to Loongson firmware, there is a distinction between a product firmware, what they called, which is fully tested, everything's I guess more conservatively laid out in order to be able to provide it to OEMs with much less hassle after the provision of the source code. But with the 2026-05 release, they came out with a community RC release, so they were more, I guess, proactive in introducing new features. For example, this time we have support for DVFS-based CPU and SoC frequency scaling for mainline kernels. So finally, when we use our upstream Linux kernels, we'll be able to get frequency scaling, and you'll also be able to enable what we call boost frequency on one of the cores by about 100 to 200 megahertz, depending on the workload. This will have to be enabled manually, but more discussion and information on that will come. We should probably write some documentation on that. And secondly, there is also the 4 kilobyte page mode for 2K3000 and 3B6000M SoCs, which previously would not be able to boot with this kernel page size. So there's now a switch in the BIOS firmware to enable this mode. Some of the colleagues from Loongson has mentioned that this might harm performance in the 16 kilobyte kernel, but with our testing with SPEC CPU, we only saw really negligible differences. So suit it how you will. Thirdly, we also have some new ACPI tables. We have first of all the firmware performance data table. So now with systemd analyzer, we'll be able to get an idea of how much time you spent during the firmware stage and the bootloader stage. There is also the IOVT table for I/O virtualization, but I personally have not tested it. I think it will be preparation for IOMMU support on a kind of a wider scale. So this firmware update is available for most reference design motherboards from Loongson, from the basically the desktop lineup. So we have Loongson 36000, 3B6000, and the 3C6000S. We also have Loongson support for Loongson 2K3000 and 3B6000M, and this would include Orange Pi Nova, which was I guess sold in limited quantities earlier this year. And this firmware will be available. It's already available update for download from longfans.cn. I'll quickly walk through how we will find the firmware as well now that we're here. So when we start from the portal site, we'll go to product database, and I think most of our friends aboard are using the 3B6000 motherboard, the V1.2 revision. So if we click on that, we'll be able to find downloads, and you'll see this 2026-05 firmware, both in debug and release version. So the release version, it boots much faster with less checks, but a lot less information available for debugging. But the debug version will have the full firmware output if you hook up a serial console to it. And we have very detailed changelog for what changed. There is way too much for me to go through during the biweekly meeting, so if you're interested, you can just read through this whole thing. I'm honestly really proud that we have a very detailed changelog now. Something that you don't always see from PC manufacturers. Anyway, we'll move on. And now for Box 64, we'll have Liu Yang.
As usual, over the past 2 weeks, we have made some progress. First, we fixed the bug found in the 6.7 prefix string operating instructions. We also added the integrity checks to the code cache loading process, so that if a cache file is corrupted somehow, box64 will refuse to load it. We optimized yet another support function for in the big block mode. We introduced a GUI configuration tool called the box64 configurator, and we also added KDE Dolphin integration so that we can take box64 configuration for any specific executable. We fixed a typo in the state transition stage of the flags emulation. This is an important fix to the flags emulation state management. And we've refactored the code pitch to make it more maintainable in the listed few places. So next page, please. And we wrapped the function called the process VM right way function. So we added a ptrace based fallback to it. There is a long story behind this. So basically, this function is used by one to do the inter-process memory writes to implement the write process memory Windows API. And a tool called the stranger.exe. This tool will use the Windows API to do the inter-process memory writes to patch another process code at runtime. But to support the self-modifying code for any code box64 discovered, it will mark the memory page as read-only so that will make the process VM right-away function failed. And with the new fallback, we are able to ignore the read-only permission and write that memory anyway. So you can see this is not perfect because if box64 already translated that code block, the translated block will not be updated. But anyway, it works. So we are fine with the current state for now. We also fixed the handling of the trace flag when it returns from a signal handler. So this allows the program to be detached from debugging mode. This is for the same tool, the stranger.exe. We also improved the handling of the tracing flag in the return emulation, and we added a RC file entry for the Windows for Wine's Explorer.exe. This disabling the big block optimization to reduce its code start time. We improved the tracking and management of the executable memory pages, and we fixed the bug where the bit shift and bit rotate instructions were marked as flag fusion enabled when the shift mount field is a register. Because when it is a register, we can't do the flags fusion. And finally, we tweaked the undefined behavior handling of the ROL and ROR instructions, both in the generic and the interpreter. And this covers all the updates for the past 2 weeks. Thanks.
Okay, thank you, Liang. I think I will quickly show what we meant by the. Never mind. I don't have my WeChat open, but basically the Dolphin plugin is very similar to what you would see in Windows. It's basically a tab in the file properties, and you will see a compatibility mode or something like that. So it should help with troubleshooting and basically finding better performance and better compatibility. So we'll move on. Now with other updates, we'll have Yang Xinhui.
Okay, let's move on to bug reports and bounties. First, we have Xu Xiaowei. He requested official LoongArch 64 Docker images for the Narcos project. This is a dynamic name resolution and configuration service from Alibaba. And DCSID reported that the sort test in highway, this is a portable SMD library, this test failed to build with toolchains like native float 16 support, such as LoongArch 16's toolchain. Since LoongArch 64 lacks native floats, like half precision floating point numbers. So after the fix, a latency issue was discovered in the getLink function. This function handles 2-byte links and calls this intrinsic function, which is invalid with emulated float 16_t, since this function lacks constructors from int. So that means any emulated float 16 won't be able to convert to float 16 to call this intrinsic function. And we have general contributions. First, we have core DNS as part of the Kubernetes dependency tree, released LoongArch Docker images since version 1.14.4, thanks to Xu Xiaowei, who had brief discussion with core DNS. And LoongArch added a LoongArch support for MEES. This is a development environment management capability. Next page, please. And we have Denis Flodrichenko. He added LoongArch build support for the core and the pipeline component from kernel CI. This is a well-known CI framework for testing Linux kernels. And we have FOTS 12.12, who fixed the bug for NCNN. This is again a neural network inference framework. This issue involves the int8 convolution operation, which could return wrong results and wrong shape when encountering one-dimensional inputs and one-by-one convolution kernels. And we have Gao Juxin, who fixed 2 LoongArch related issues in the starvation test of the LTP automated testing framework. The first is it avoided the automatic calibration process to override the state of the -t option specified in the command line. And second, it skipped the test for kernels with voluntary preemption model due to hardware constraints. Since I think, if I recall it right, on 3B6000 and 3C6000, the amount of let me check that real quick. Yeah. So on LoongArch 3C6000 with 250 tick rate, the signal workload is limited by scheduler tick latency, not by signal delivery cost. So on such platforms, the preemption model really doesn't matter. And we have one rig added fiber support for WSM time, a WebAssembly runtime, and we have Victor Bash 400 imported the patches adding LoongArch ABI detection, which had been previously rejected by FastFetch's upstream developer, who stated that I don't use, and I probably won't use LoongArch hardware. So do the rest of the fast fetch users, which is a bit of absurd. So Victor Batch 400 took the patches and merged them to his own fast fetch fork. So any interested ones, please check out his fork. Next page, please. Okay, we have Zhao Qiankang added LoongArch support for Go TMP tools from Google, a tool set for controlling TPM as well as Microsoft's TPM 2.0 reference implementation. We have Wu Kaiyang, who posted a bounty requesting LoongArch support for Too Many Cooks, a multi-threading library written in C++20, which has become a dependency of Telegram desktop since version 6.9.3. So Xiroyao subsequently added the LoongArch support to the library, and TZCNT, the maintainer of Too Many Cooks, filed a PR updating the library dependency for Telegram desktop. So the master branch now builds on LoongArch 64. That should conclude the updates in the past 2 weeks. Thank you.
All right, thank you, Yang Xinhui. Okay, now I think we'll skip the per section Q&A since there was rarely any questions at this stage. So we'll move on to distro and operating system updates. So first of all, so this is the first time this segment has came up in the English session, but we have had that in the Chinese session, but not for the past couple of times. But anyway, so these are tips for distro maintainers that, something to take note of. Something we found during distro maintenance. So first of all, please consider disabling the following kernel configurations. So we have once again checked these options and found that they're still broken. So first of all, we have the HSA AMD P2P. This would cause Llama CPP to output garbage on systems with multiple GPUs. This is likely caused by the fact that the current Loongson platforms, their PCIe peer-to-peer support might be broken. Something to look into. The Arch write combine option also should be disabled because it will cause random rendering artifacts on AMD GPUs, and on Intel GPUs we'll see initialization failures. So this issue was reported during the second session, but is still present in the 7.0 kernels. So yeah. And as mentioned before, please consider backporting this pull request from Telegram to make sure that it builds on LoongArch. This version introduces Too Many Cooks, which did not have LoongArch support at the beginning. And if your 7.0 kernel locks up during booting on a virtualized machine, please backport the patch set from the 7.1 branch and maybe suggest for it to be backported to the stable branch. And finally, the Long VPU and Long GPU drivers have been updated to support Linux 7.1 thanks to Xiroyao, so you'll be able to find the patch sets from the links below. And that will be all for the tips. Now moving on to AOSC, we have released cores 13.3 with GCC now updated to 15.3.0 with various LoongArch related fixes. There are other notable updates as well. We have updated the Linux kernel to 7.0.12 with a functional fix for ROCm on systems with multiple GPUs. So that will be the option we mentioned before. ROCm the ROC 7.13 has been rolled out. Firefox and Thunderbird have been updated to 152 with many security fixes. The Boost library has been updated to 1.91. So that would enable us to build newer versions of certain software. In the past 2 weeks as well, we have shipped 27 security updates, fixing 5 critical and 71 high severity vulnerabilities. So affecting, for example, gRPC before 1.81 really has a critical authentication bypass vulnerability. There are also several critical ones affecting OpenSSL. there are also three critical vulnerabilities affecting container D before 2.3.2. So in any case, we'll encourage that you update your system as soon as possible. And to the right, you have the QR code to our Telegram group. And if you're interested, please join us. And now for Proxmox VE, I'll move the microphone to Wu Kaiyang.
So for Proxmox VE, we finally have our first ISO installation image available. In the past few weeks, Zixing Liu and me have been working on the installation medium. Despite not hearing back from Proxmox company, we wrote our own script to build the image. So now you can download our image here in the link below. And our scripts are publicly available at this GitHub repository. As always, feedbacks are welcome.
All right, thank you, Wu Kaiyang. And I think in the next couple of weeks, we'll be working with Aleksandr Shoris on a website for this project as well. And now moving on to Basalt, we have again Baltayev.
Hello. During the last 2 weeks, we finished verification of alt server, and we are proud to announce that soon it will be released officially. We going to release workstation and alt server during this summer. It means really a lot for us. And we moved to adopting alt virtualization for LoongArch. It's a fork for PVE. We are really close to upstream, and we'll share details about it a bit later. Right now, majority of our team focused on performance for alt kernel on LoongArch. We made a stress test. It's a bit disappointing. LongNix are working way better. And we need to investigate these issues, and we are open to any hints, hacks, how to adjust settings for kernel to act good for Loongson. That's it for now.
Probably just move on to the special presentation we have with Aleksandr Zubankov.
Hello, do you hear me?
Yes, and we'll now switch to your PDF.
Okay. Should I demonstrate my presentation or?
No,
okay.
you can just go. Tell me to switch pages, so it's easier for. Yeah.
Okay, no problem. Okay, we can start. And today I would like to present you my presentation about Loongson performance estimations in benchmarks. The first part of the report is dedicated to embedded processors. In the future reports, I will show comparison of desktop and server processors. Let's start. Next slide. First is introduction. Our approach to estimate performance is used any benchmark suite from developer and entity fix to evaluate spoof performance. For each CPU, we use GCC compiler with O3 optimization and MArch and MTune. For Loongson, we use GCC 830. This is due to the tests were conducted quite a long time ago, and there was a fairly limited time, and we conducted tests on the provided OS. It's LongNix and Kylin. For Elbrus, we used our operation system is Colobos first version. Elbrus has optimizing compiler LCC, that's GCC 11.3.0 compatible. For Intel, we use Fedora 43 and GCC 14. For MediaTek, we use Ubuntu, and GC 13. And Rock chip we use Orange Pi OS based on Arch Linux with GC 15. Most benchmarks designed as single thread calculations, but it has also multi-threaded benchmarks, and we present results for maximum number of threads to estimate performance of all chip. All benchmarks we run 10 times to estimate mean and standard deviation. Next slide. This is a Loongson CPU lineup. In this test we look only at 2K3000 and 3B6000M processors. Unlike to latest desktop and server CPUs, they only have LA364E cores and lack LAS-X instructions. They also didn't have L3 cache, but they have a fairly large L2 cache, which is common for system on chip. Next slide. Next slide, please.
I already have.
This. Okay, this is our tested devices, two Longsons and Banana Pi that's used is my home Wi-Fi router, and also we tested Elbrus and Orange Pi. Next slide. At this slide you can see characteristics of used CPUs. These have a different number of threads. 3B6000M is 4-thread version. Loongson 2K3000 is 8 threads, and some other CPUs you can compare characteristics. You can note that Rock chip have complex configuration, consists of different ARM cores, 4 Cortex A76 and Cortex A55. And Rock chip has a L3 cache. Some CPUs have SODIMM RAM, and other one was soldered. Next slide. Let's go to benchmarks. First benchmark is Whetstone, first general purpose benchmark. It estimates float point speed, but with time independent integer benchmark functions. Benchmark use 8 tests, 3 of which perform standard float point and calculations, 2 with cosinus and exponential functions, and 1 of each for integer branching or memory allocation. On next slide you can see performance in single thread benchmark. Let's wait the slide. This you can see that Loongson give pretty good performance, some lower than Cortex A76 in Rock chip, but significantly better than Elbrus and MediaTek. In next slide this performance in multi-thread, and there you see that Loongson 2K3000, due to it has similar cores that have more performance in comparison with Cortex A55. It's pretty close to ROG chip. Next slide. Next benchmark is Drystone. It is a synthetic computing benchmark to represent integer performance. Output from this benchmark in number of Drystone per second. This is obsolete benchmark, but we also use it. Next slide. This benchmark is only single-threaded, and there you see the same trend of performance. Loongson 3 B6000M is quite better than Loongson 2K3000 due to it has more frequency, 2.3 GHz versus 2 GHz. Let's go to next slide. This Cormark benchmark, simple but yet sophisticated benchmark that's designed to test functionality of core. It's produced a single number scores, allowing users to make a comparison between processors. It contains the following algorithms: list processing, matrix manipulation, state machine, and CRC cyclic reduction check. Next slide. The first is single thread results. There you see that Loongson is shows quite good performance in comparison with Intel and ROG chip. And next slide is multi-threaded results, and there you see that Loongson 2K3000 are better than all of other chips in this comparison. Next slide. Next benchmark is Super P that calculate P number to a specified number of decimal places. In our case is about 4 million. It uses Gauss-Legendre algorithm. Next slide. At this histogram, a better result is lower. This is the time, and best time shows Loongson. Loongson shows best time. It's pretty good. Next slide. Next benchmark is LeanPack, measure floating point computing performance. It measures how fast CPU solves a dense matrix 100 by 100 of linear equations. This is a common problem in engineering. In next slide you see results of this benchmark, and there somewhat ROG chip have a better performance. Next slide. And Livermore loops benchmark is more complex than LeanPack. It consists of 24 loops taken from operation programs used in Livermore National Laboratory, and they are a mixture of vectorizable and non-vectorizable loops, and test the computational capabilities of hardware and software in compiling and vectorizing efficient code. In next slide, you can see results. It have 5 metrics: max rate, maximum performance, average, geometric mean, harmonic mean, and minimum rate. There you see that Elbrus 2Z3 can take a better result in max rate, but mean rate is lowest in this comparison, and this is no good result, and such complex benchmark can show performance of processor in more complex operation, and there I think better results shows ROC chip. Next slide. Next benchmark is SciMark, composite benchmark that measures the performance of numerical codes used in scientific and engineering applications. It consists of 5 computational cores: fast Fourier transaction, Gauss-Seidel relaxations, sparse matrix multiplication, and Monte Carlo integration, and also dense LU factorization. The problem sizes are intentionally kept small to isolate the impact of memory hierarchy and focus on the compiler and processors. Next slide. This is the result. You see that all processors is pretty close to each other, except MediaTek and ROC chip. There some better ROC chip, and MediaTek is bad. Next slide. Let's go to memory tests. The stream benchmark is synthetic benchmark that measures sustainable main memory bandwidth in megabyte per second and corresponding computational rate for simple vector kernels. Stream used for kernels for analysis. Copy measure transfers rates in absence of arithmetics. Scale adds a simple arithmetic operation. Sum adds a third operand to allow multiple load store ports on vector machines to be tested. And triad allows chained, overlapped, fused, multiplied, add operations. And next slide. And there is the result. It's maybe quite strange, but I think that ROC chip shows better results due to it has memory LPDDR4X, and maybe it's more faster than other CPUs, and there we see such result. Next slide. And the same trend. Next slide. Next benchmark is memspeed. Performs 3 different sets of single and double precision floating point and integer calculation across 2 data arrays. Next slide. And the result I showed as 2-dimensional histogram. Yeah, 2-dimensional histogram that better result is showed by brighter color, and there we can estimate size of caches, and if we see at Y axis at 64 kilobytes on Longsons is L1 cache, and after that only L2 cache, and after that is RAM. Next slide. Next benchmark is bus speed. It's a benchmark intended to demonstrate maximum data transfer speed from buses and caches. Program starts by reading one world with a large address increment for the next one. The increment being reduced by half for following measurements until the data is read. This identifies where data is read in burst and provides a means of estimating bus and maximum RAM speed. Next slide. There we can estimate speeds of RAM and caches for different data types. I think all processors shows good result, but Intel is better, as I see. Next slide. And one of the last benchmarks is NPM flops. The benchmark carries out calculation of provided form, which 2, 8, and 32 operations per input data vault via caches and RAM. Each thread deals with separate segments of the data via shared code, fully demonstrating multi-threading speed gains. Next slide. There is the result. Best results show Elbrus. It's maybe due to it has 2-channel DDR4 memory, but Loongson and Rockchip shows also good result. Next slide. Go to conclusions. It's very short. Loongson 2K3000 and 3B6000M showed a good result for a single board computer, being only 1.5 times slower than a Rockchip 3588 in some single thread tasks, and 1.5 and 2 times faster than MediaTek, and 3 times faster than Elbrus in our tests. And thank you for your attention. You can ask me your questions.
Thank you, Aleksandr. Let's now move on to question and answer. Do we have any questions from the meeting side? I think there are 3. I guess I'll start with a question, Aleksandr. So I guess one of the benchmarks that really surprised me was with the stream benchmark. Do you have any sort of speculations or guesses as to why this difference exists between the 2K3000 and the 3588, which are both, I believe, single memory channel platforms?
I don't know in which configuration TB6000. It's some box that you see at one of the first slides. and I don't know which memory configuration it has. But Loongson 2K3000 has one DDR4 memory, so dim, but I don't know about frequency. Yeah.
Understood. Yeah, the 2K3000 it is rated for a higher speed, but I think the board that you have tested is of a lower frequency. But understood. Okay. Yep. Okay, I'll leave the questions for others. If you have, for those who are on Zoom, if you have questions, you're welcome to just open your mic and ask them.
Alexander here. One interesting part would be also TDP, or the power consumption in comparison, because they are a little bit different, I guess. Some are more embedded based, other more desktop based, and sometimes what intrigued me, the performance was almost the same, although the configuration, as was pointed out, was very different, well, kind of different. And the power consumption with all the optimizations also coming, that's also very interesting to see. Okay, maybe it's slower, but maybe if it's using much less power, it must be more interesting to embed it or to mobile use than another CPU that may be 10% faster, but consumes like 50% more power. So that's something for the future, I guess.
Yeah, thank you. Unfortunately, we didn't measure power consumption of these two devices of Longsons, and don't know how much it eats. But we test desktop 3A6000 and server 3C6000S. Power consumptions I showed it at 2 slides before, and I think yes, necessary to estimate performance in different TDP ranges. It will be interesting to see.
Yes, I think performance in relation to power consumption is also a very important dimension for I guess cross-platform comparisons as well. There are a couple questions on the let's start with a couple questions from Biweekly as well. Since they're asked in Chinese, I'll basically ask the question in English and again in Chinese so that they understand what is happening. Okay, so the first one is from a friend who asked, is LinPack's performance, which was significantly, I think, lower than lower than the RK3588, is it due to the lack of memory barriers and the lack of 256-bit vector?
In which comparison? Sorry.
In the LinPack comparison. The current one showing on.
Why Loongson is why Rockchip is better?
Yes.
Or yes. This is a single thread mode, and I think that Cortex A76 has more performance in comparison with LA364E. Maybe it's also due to optimization, some or old version of compilers also.
好的，刚刚讲者回答这边认为是有几个因素，一个是可能是处理器本身的规模较小，另外一方面是软件本身，因为这个 LinPack 底层的库，它的是否对龙架构有充分的优化，以及就是 它目前这个使用的这个 GCC 8.3这个版本是否有性能上的劣势。Okay, and I'll move on to the next one. The next question asks, why are we testing the 4-threaded 3B6000M? I think I'll just take this question. So the 3B6000M is available both as an 8-core processor, which will be its full SoC form, but there is a variant that is available as a 4-core that's targeted at thin client, where you lose four of the cores. You also lose the GPU, so you only have a 2D accelerated display controller, and you also lose encoding in VPU. 好，我现在用中文重复一次这个，就是 3B6000M 它是有2个版本的，它有一个完整的8核的版本，这个是一个完整的准桌面积的 SoC。那么它还有一个4核的版本，它这个主要就是面向授客户机的。那么这个版本它除了少了4个核心之外，它还有几个区别，就是首先它的那个 LG200是没有 GPU 部分的，它只有一个显示控制器，也就是说它只有2D 加速，以及就是它在那个它的 VPU 就是它的那个视频处理器里边，它是没有编码功能的，所以就是这个 3B6000M 的4核版本，它实际上是一个功能也是受限的一个版本，就是完全是2回事。Okay, let's see if we have other questions. I see Vladislav has his mic open. Do you have any questions? Okay, I think it's just coincidental. Yes, I think again for Alexander, what was the reason for choosing the GCC 8.3 for this benchmark?
I use this GCC was used is due to tests were conducted quite a long time ago, and there was a fairly limited time for testing, and we use provided operation systems, Loongson Kylin for these devices, and in our plans to make comparison in more recent versions of GCC in our operation systems, and for also for others devices too.
Okay, understood. I think it will be interesting, I think, at least to retest some of them on mainline GCC. It might sound funny, but the current GCC version is already twice that of 8.3, so it could be interesting to test as well. Okay, another question from Billy, who observed the 4-core 3B6000M's LinPack results seems to be higher than the 2K3000. And this one is fairly easy to explain because the 3B6000M was rated at 2.3 gigahertz, and the 2K3000 was running at a lower clock speed. 就是这2个处理器它的那个当时运行的那个频率是有显著区别的，一个是 2.3G， 一个是2G， 这个从结果上基本上是可以解释得了的。Okay, do we have any questions for either this presentation or for the information from before? And I think there was a screenshot from Liu Yang. This is what he mentioned for the Dolphin plugin would look like. It's basically something very similar to what you see on Windows. It's a extra tab to control the profile you'll be using with Box64.
Your screenshot is not displaying in the screen share, so maybe you should insert it to one of the slides and full screen it.
Is it not?
Yeah.
1 second. Are you sure? Because I can see it even on the live stream.
Oh, that must be Zoom's problem.
Okay. We'll share the screenshot later.
You might want to.
Yes.
You want
we'll
to
send it
you
somewhere.
want to
Yes.
insert it.
Yes. Okay. So before we end, the next meeting will be on July the 9th, 2026, same time. We'll have a presentation, I think, on UEFI again on another topic. Until then, we'll see you in 2 weeks, and you're welcome to join our Telegram channel and Discord server if you need to. Okay, thank you everyone for joining us, and we will see you in 2 weeks.